All right, so there's another update that I want to give. It's a short update on this time. Really, the only thing happening in the code is the fact that the data that is stored here for these various node points always had an extra step where we had to reset it up. We had to re-execute it. And I've never run that one to actually store its data. Usually that is pushed through from another source, but I decided that for the series I wanted to do this, and I found some ugly issues. For instance, an exponentially increasing time to execute the save of it. So let me show you what the actual change is. So on this one, when I initialize the steps, I tell it to initialize, it runs it. I could have it process every step and not show us instant, but do it this way so we can see the changes. Same stuff as normal. And I'm just going to have it stop. We'll just go back to instant. But anyway, so we're reforming these shapes, and now I want to save that data. So down here, I actually have the JSON data exposed. And after I did this as a test, it occurred to me I should keep this exposed as a way to take that data for the node map and basically just save it out. And then if I put in new data to it, let's see, I'll take this, Control-C, and go to here and paste it. Then we see that I get this new, or this old one back to it, just by pasting in the new JSON content, or the existing JSON content. Where's my mouse? There it is. Okay, so that's useful. Now, following a normal serialization route for Unity left this at a really serious issue, and I want to talk about what that is and show you what the exact code change is. This, of course, will be checked in for the video, committed for the video. All right, so in force graph, whoops, no, I want force graph, terrain mod layer. For force graph itself, the solution that I had originally was just to go into force graph and add this. System.Serializable, which it was not originally serializable. This node class underneath it was also not serializable. Now, this works. It works, and the first time I run it, it's great. We're getting about like 0.7 seconds or something for the test data that I'm running. It runs at the same rate to actually execute it. The problem is afterwards, after I run it again, it takes almost a minute. And then after that, it takes several minutes. If I run it 2 times or 3 times. Now, I'm not sure what exactly is going on, but it does seem like there are basically 300 million calculations going on for the settings that I have right now to get that force graph to execute. And I think what's happening is it's triggering a serialization on most of those steps, or on a certain number of those steps. And so it takes longer. The problem that it doesn't quite balance out is the fact that when I have this in here, so literally just putting the system serializable on this one does resolve it, it does save, it does come back, but it was taking an exponentially longer period of time. So I had to remove it. I wanted to walk through this in case someone else decides I want to put in the serialization. I want that data saved because, quite frankly, it's easier to manage. Okay, so the alternative is, one, I needed to make node serializable at least. Not this one. I can't let Unity handle the serialization on it. As soon as I expose that, that's where I run into those timeout issues, or those timing issues. And Unity just freezes up. And there is no escape but killing Unity. All right, so that is nothing to save there. Well, whatever, I saved it. Okay, then we have force graph terrain mod layer. This is the one that's actually referencing it. So inside of here we have force graph. So I have force graph here that I'm referencing. When it was serialized, then every change to this or to that class ended up serializing up into this terrain mod layer is, I believe, a scriptable. Yeah, it's a scriptable object. So it was rolling up the serialization into that, and that was triggering its changes, which if I'm right, then the change to every single node inside of there was triggering the reserialization of that node, which re-triggered the serialization of the parent object or the force graph, which re-triggered this one for the force graph terrain modeler. So that was a lot of painful repetition of what it needed to do, when really I just needed it to happen at the end. So here's the alternative. For the force graph mod layer, I ended up putting on the serialization callback receiver. This also makes, just to be clear, this also makes the data, all of this code, support recompile and continue, which means this code will remember all of its settings even if we shut off the project and bring it back, even if we change code while the game is running, which this is an editor tool right now. It's not being designed for the game to run, but I still prefer my code to support that. Okay, so that interface adds these two classes, or these two objects: on before serialize and on after deserialize. So basically, before Unity makes its serialization, that it's going to serialize the document or the content, it calls this method, which is basically what allows us to serialize dictionaries, for instance, when we want to. Go ahead and look up how to serialize dictionaries in Unity, and this is the key reference. Or look up the serialization callback receiver for Unity, because it gives a dictionary serialization example for its default. Okay, so in this one, test JSON save. Oh yeah, I put in something to trigger the saving and loading, but turns out that's not necessary. So I'm going to get rid of that. I'm going to get rid of this one, and I'm also going to get rid of its other call up at the top in a minute. This was part of some test code changes. So inside of here, we're basically saying we have this public string, and I have it saved as a text area, so from 1 line to 20 lines, depending on the length. Or it'll go longer. It'll just include scroll bars. So next, I'm basically serializing the force graph. I'm serializing the force graph, the entire force graph at that point. Now, the JSON convert is part of Newtonsoft. So I did import the Newtonsoft library for this, because the Unity library doesn't serialize it if it's not marked as serializable or already part of a Unity object, such as component or scriptable object. Okay, I did put format indented. I could switch this to a smaller version, but I prefer this because of its human readability and allows handwritten editing. Although, since we are preserving objects, because these objects have child nodes which have connections back and forth to other nodes in the same list. And because of that, it makes this repeating loop. Now, Newtonsoft serialization includes this for preserving the references. So it deals with it. Great, that's off my hands. That allows our serialization to work, and that's basically it. We're using Newtonsoft JSON convert to serialize an object with the specific setting that it handle references. Okay, great. Now, because of the fact that it's handling references, it makes it a little weird looking in the code, so it's not that human readable anymore, which kind of misses some of the point, and I kind of wish there was a better structure that they had for this. For instance, put in the IDs for each one of these. So you can see here's the nodes. Okay, this is the node for number 2. And then over here we have connected nodes that are on it. And then from there, it's actually building out all the references and child objects. And then eventually I get to positions like this one belongs to 6, I think. But whatever the case is, these are getting harder to read for their positions. And so that's not a great solution. I don't like Newtonsoft's solution to saving this. Honestly, I think it really should have just been, here is a special key JSON word at the end that can't match up with what you might find as a JavaScript function name or a C# function name, though I'm not sure how possible that is. Anyway, but then include all your referencing and IDs and paths within that, and have it as a separate list structure where it puts the address of each one and where to connect it, and put individual unique keys such as IDs in each one of these. And that would have solved it and been far more humanly readable. But I'm not trying to solve that technology here. Okay, so Right before this serializes, I take the force graph and convert it to a JSON that then sits inside of this string. Now it's a public string field that is inside of a scriptable object, so it's serialized. It gets serialized with the data. After deserialize, which basically after you reload Unity or Unity gets an update to its code, it comes back here and we basically say, if we have this string, because the deserialization happened, and so if we had this string before, we should have it again. It checks to see, does this string equal something? If it doesn't, it escapes right away. But assuming it does, we call the convert function to convert it back to a force graph. That's it. It works, it's clean, it's fast. This basically happens only at the serialization of the top layer object. And if things aren't triggering those changes continuously on it, that should be fine. Something that could potentially harm it, before on this mod layer, we were holding on to the mesh data. Now the mesh data isn't exposed, and I'm not positive whether or not Unity is actually serializing it. It's a two-dimensional float array. It might not. I would understand if it does either way. I just haven't verified it. Okay, so if we had some large amount of data being stored in this, and this wasn't just being used as a visualizer tool, which also kind of makes this a bad place to put this piece of code, but it works for now. Then anyway, that could be triggering that serialization and deserialization process, because basically anytime you change a field, it wants to reserialize. I'm not sure if it's anytime you change a field or if it is a field got changed while you were executing, so it got marked dirty, and then it reserializes at the end of the frame. I don't know if it operates like that. But because of the fact the timeline was getting much larger, that I was seeing it suddenly go from like 0.7 seconds to 1.5 seconds for this processing time to suddenly turn into 1 minute and 48 seconds, that signifies to me that there's some sort of and serialization was the only change, literally adding the serialization tag. I have to assume that serialization was getting executed a great number of times. Okay, that's it. Oh yeah, I didn't need these ones, these test JSONs. That was to trigger or to force a save. But with this one, the recompilation should have happened, and so these JSONs should disappear. Oh, they haven't yet. Did I save that? I did. Oh, I left an error in my code. Oh, I had this. Okay, got it. Goodbye. All right, so that's recompiling. Before, these variables would have been lost because it's part of force graph, which is not serialized with the object. Now it is. We have a system in there to deal with it. All right, and of course I can re-execute and get new shapes or whatever it is I want. All right, that's it for this video. I hope you found it useful. I know it wasn't exactly going into new technology features with this, but honestly, its usability is also really important to me. I don't want to just give you something that it works in a very fine-tuned scenario. I want to make sure that we have the specifics worked out, that this is ultimately a usable product in the end. Okay, thanks.